Dear student, now I like to discuss viewing transformation. Sometimes an image may be very complex. It is difficult to read. In such situation, it is useful if we display only the interested portion of an image. The interested portions which we want to select of an image, the selected portions of the image for display is called window, and an area on a display device to which the window is mapped is called viewport, and the coordinate of the window is transformed into viewport or device coordinate is called viewing transformation or window to viewport transformation. So the coordinate transform from window port to viewport, that is window to viewport transformation. To do this, there are 3 steps to transform from window coordinate to viewport coordinate. So step 1, translate the object along with window until the lower left corner of the window is at origin. For example, suppose an object like this, I want to select a portion, interested portion, I want to visualize or display only that portion, only selected portion in a screen in a better way, or magnify or minimize. These are my interested portions. So this portion is called window. Now first step, translate the object along with window to the origin, that is 0 0 origin, x-axis, y-axis. After translate, it may be look like this. So here is the window come at 0 0 position. So it may be like this. Okay. X-axis, y-axis. Second step, the object and the window are now scale up or scale down until the same dimension of the viewport. So this is window port is magnify or minimize, scale up or scale down, magnifies or minimize is same as the viewport. Viewport means where the device where we want to display the exact portions. So the viewport, suppose I consider the viewport like this. So this image, okay, so this image scaling, after scaling the viewport so it may be like this. So window port is scale up or scale down with the same dimension as the viewport. dimension. Similarly, object will be minimized if the viewport is minimized. If the viewport is maximized or dimension is larger than window, then it will be maximized. If the window size and viewport size is same dimension, that means same object will be displayed. Okay, so there are no distortion. If the size of the viewport is changes not same as window size, then object will be distortion. Okay, step 3, viewport along with object will be translate to the desired position of the screen. So this object, this portion will be translated in the screen where we want to display. So viewport object is, now this object will be translate the viewport translate the device screen. So I want to display here that portion, top right corner I want to display. So it will be only that portion will be displayed and not display that portion. In the screen only this portion will be displayed. This portion will be translated here in the screen. Okay, now for that to do this, first translation operation. So to translate an object, we know the translation matrix. So here I consider the lower left corner of the window, lower left corner, that is WL, window left, window right, W bottom, W top. That means window lower left corner is WL, WB. Okay. Similarly, in case of viewport, not necessary it is always in 0, 0 coordinate. It may be in other portion, other corner of the other coordinate of the x and y axis. So in general I consider the viewport lower left corner is VL, top right VR right side, VB bottom, and V top. Okay, in that case it is 0, 0, or not necessary it is always 0, 0. So in generalized form, lower left corner is VL, VB, left side viewport, bottom side viewport. Okay, so now, so first translate the object along with window lower left corner to the origin. So that amount we have to show translation matrix. So step 1, translation matrix is 1 0 1 0 minus WL, because I have to translate that amount. WL amount I have to decrease to come to the 0, 0 lower left corner, and you represent in column measure order and in homogeneous coordinate. 0 1 minus WB 0 0 1. Similarly, number 2, translation matrix. Next, the object and the window is now scale up or scale down, same size as dimension of the viewport. So scaling factor, no scaling factor Sx along x direction, Sx scaling factor is size of the viewport, width of the viewport divided by width of the window port. Width of viewport divided by width of width of window port. Similarly, sy that is scaling factor along y direction, height of viewport, height of window port. So matrix is Sx 0 0 0 sy 0 0 0 1. So Sx equal to width of window port, viewport, that is Vr minus Vl, V right side minus V left side, Wr minus Wl. Similarly, and Sy equal to V top minus V bottom divided by W top minus W bottom. This width minus this width, and this width, this viewport length, viewport height divided by window port height. Okay. Third step is translation. Translate the viewport along with object to the desired location of the screen. Desired location of the screen. So in screen, desired location of the screen. So again I need translation. So translation amount, it depends on the size of the viewport, where the viewport will be displayed. So this viewport, this is viewport. Viewport will be translated from origin to the particular desired location, viewport location. So that is viewport V, L, VL, VR, VB, VT. So translation of viewport to the screen, so Tx, translation Tx equal to VL plus VL, and Ty equal to VB. That amount 0 0 to that amount along x-axis, along y-axis I have to increase or translate. So translation matrix 1 0 VB, 1 0 VL, 0 1 VB, 0 0 1. Okay, so the final transformation matrix is matrix is A matrix equal to 1 0 minus WL 0 1 minus WB 0 0 1 into Sx 0 0 0 Sy 0 0 0 1 into 1 0 VL 0 1 VB 0 0 1 and right to left, multiply right to left. So this matrix into this matrix, first resultant matrix will be multiplied with third one. So I will get, we get final matrix transformation final equal to, ultimate we will get Sx 0 Sx 0 VL minus WL into Sx 0 Sy VB minus WB into Sy 0 0 1 is the final. If I multiply this matrix into this matrix, resultant matrix multiply with that one, then I will come, it will come this final matrix. Sx equal to width of the V port divided by height of width of the window port, that is the scaling factor along x-axis. Sy means scaling factor of y direction, that is height of viewport divided by height of window port. Vt minus Vb divided by Wt minus WB. Okay, thank you.